Hi, in this video I present to you our position on the need for evaluating MR interaction techniques. My name is Patrick Harms and I'm from the Nuremberg Institute of Technology. Some years ago we started our research on utilizing state-of-the-art MR systems for evaluating the usability of technical devices. For this we put virtual prototypes of these devices into MR and asked users to interact with them. One of the first questions that came up was, how do we implement the interaction? So how can, for example, users with some kind of VR controller interact with rather small buttons on a virtual prototype? To find out, we performed diverse studies. In these studies for VR, we found out, for example, that if users have to press these small buttons, then an interaction technique based on hand tracking actually performs quite well, because users can naturally press these buttons. But if they have to move a virtual object, for example, put a virtual coffee cup under the outlet of a coffee machine, then a controller-based interaction works best. We had similar contradictory results also for smartphone-based AR. So what were the first major outcomes of these studies? We found out that there are definitely some interaction techniques that outperform others. But what we also found out is that even the best interaction technique may come up with some compromises, or you may have multiple interaction techniques that serve on a similar level of quality, but both come with different compromises. And if you have the situation, you may want to find out in the long run which of these interaction techniques is then still the best one. And for this, we try to apply a further evaluation approach, which is based on an automated usability evaluation approach for MR systems that we developed in our research group. How did we do that? We first recorded on an event level how users interacted with an MR. Then the approach automatically determines patterns of user interaction. And then it assesses these patterns for suspicious types of patterns that may indicate a usability issue. What we basically found out is that if users really had problems with a certain interaction method, then we also find more of these suspicious patterns. In the end, this let us conclude that we have multiple approaches to assess the interaction techniques for MR, and those should probably be applied not only by us, but also by others in the community. And that's why we propose the following approach to evaluate interaction techniques of MR systems. First of all, developers should find out which types of interactions are users likely to take inside of the planned MR system. Then they should implement diverse interaction techniques and test whether these can serve the identified interaction types. Afterwards, they will find out a small number of interaction techniques that serve best, and they can use them to implement the MR system. If they have multiple interaction techniques implemented, they can release the MR system with these multiple ones and can perform some kind of A/B testing, for example, record how the users actually interact with the MR system, analyze the recorded data with, for example, our automated approach, and afterwards decide which of the interaction techniques in the long run actually perform best. And then they can create new releases of their MR system and check again. And with this, I come to an end. Thank you for watching the video and see you at the conference. Bye bye.